Alright, so we're starting today with factoring practice. And again, we start this one by looking to see if I can divide every single term by the same thing. And in this case, yes, we can. So into the 6, the 48, and the 120, they are in fact all divisible by 6. So I'm going to divide out 6 from all of them. Can I take any x's out of all of them?
1.
Yes. Just one x though. And so I'm going to pull 6x outside of my parentheses. When I do that, I am left inside with x squared minus 8x minus 20. Notice no x on the 20 because I pulled that x out. Alright, and then we're left with the question of can we factor it further? And because this is a quadratic, there's at least a chance that it will factor further. So we're going to look to see, will it go into this form? And I know whether it can or can't based on whether there are two numbers that add to -8 and multiply to -20. Is there such a combination of numbers? Yes, there is. You hopefully are coming to 10 and 2. Because I'm multiplying to a -20, so I know one of those has to be positive, one of them has to be negative. And if I'm going to add to a -8, that means I need to have more negatives than I have positives. So a -10 and a +2 gets us to that destination. This then is fully factored. It cannot go any further past that. Now this one, the factoring stuff, it's practice of kind of general stuff that's been a theme all year. Another theme all year that we haven't discussed together in a little while, so I want to throw one back in here, is our logarithms. Because pretty soon we're going to actually do some calculations with these, so we want to refresh our memory. Please just take a moment, write our exponential as a logarithm, and then write that logarithm as an exponential. So for that first one, it is currently in exponential form. We need to write it as a logarithm. So the very first thing I'm going to write is log. Alright, so the next thing that gets written in is the base of my logarithm. The base of the logarithm is the same as the base of the exponential. It's whatever's raised to the power. And so this is going to be log base 2. Make sure you are writing it smaller and lower. Then the next thing that we write in is, well, do you remember? What if you didn't remember? Because this is what I often find is people have the most trouble remembering that part right there. Well, what if I skip it for the moment? What does log always equal? Yeah, log always equals the exponent. Okay, so I can know that's the W over there. So what if you're forgetting what goes in here? Process of elimination just told you, right? It's got to be the one thing we haven't used yet, the 16. And so that would be our logarithm. That's our answer. Now you notice I wrote the parentheses in there. That's just to help you remember that technically they are there, even though when we write these, we tend to leave them out. So if instead you had written log base 2 16 equals W, that does mean the same thing with or without the parentheses. Just realize that when we write it this way, we're being a little bit sloppy. We're cutting a little bit of a corner there. So when you do these problems like on WAMAP or something like that on the computer, it's not going to let you be sloppy. You will have to include the parentheses there. All right. For our other problem here, we're taking our logarithm and we're writing this logarithm as an exponential. And so basically I'm going to be writing it in this form up here. So the very first thing I grab again is the base, which is 5. And it's going to be to the power of, well, log always equals the exponent, right? So that's 125, which equals then z. And thank goodness we don't have to calculate that one, because that would be an outrageously large number. And so then this is now written as an exponential. So we're only going to do one other problem together today, but it is one of the big ones. We're going to be doing another quadratic equation one, where we're going to write the quadratic equation passing through those points. So please start by writing down this problem, and then we'll get started on it at least together before I let you loose on it on your own. Now I know some of you are looking at this and saying, what points? Because it shows up here that we're writing a quadratic equation. Okay, fine, we did that yesterday. Passing through the points, but you don't see points, perhaps. But you actually do have points here. Because like, as I take a look at this first statement, that negative 1 there, what is the negative 1? Is that your x or your y?
Your x.
Yeah, negative 1 is the x. What's our y coordinate? Negative 17. Notice it is a point. When I take a look at those, I really want to internalize each of them as a point. And so yes, we do have the points given there. So now go back to the work that we did yesterday, the last problem that we did together yesterday, and go through and now write the quadratic equation. So start by setting up your system and going from there. All right, so let's make sure that you're headed in the right direction. You're taking each of those points and you're plugging it into that generic quadratic equation. That generic one, of course, is y equals ax squared plus bx plus c. That's in our notes from yesterday. And we're just taking each of the points and plugging them in to create our new system of equations here, which we then will be able to use and solve as we go forward. And then once we get here, well, then we simplify. So like I'm going to be doing the negative 1 squared, which of course is positive 1. I'll be doing the 1 squared, which is another positive 1. I'll be doing the 4 squared, which is 16. And when I do that work and just tidy it up a little bit, this is the same system, just actually doing the multiplication and writing it like we're used to seeing it. And then I have to start planning a little bit. I need to decide which variable am I going to try to eliminate twice. And you can make a very good argument for a couple different options here. Personally, it's so often with these that the C's cancel out nicely that I'm just kind of in the habit of having the C's cancel out. But if you chose to work with the A's, I mean, you can make that work, but even the B's are set up pretty darn well for this. So you could have gone with either of those as well, but I will be doing it by eliminating the C's. Because in order to make the C's eliminate, all I really need to do is multiply that first equation by negative 1, and then it's good to go. So now I can go ahead and grab two equations, add them. Grab two other equations, and add them. All right, so first up, like I might grab equations 1 and 2 here and add those up. If I add those two equations together, just 1 and 2, I end up with 20 equals 2b. Because you'll notice the A's and the C's canceled out in this case. That just made our lives fairly convenient, didn't it? Because after I added those down, if 20 equals 2b, then I know that 10 equals b. I just figured out one of my variable values. That helps us immensely. But of course, it still doesn't get us out of the next step of doing another combination. And so then I need to pick, okay, what's another pair that I'm going to go ahead and add? And in this case, for the next one, I'm going to go ahead and pick next to add the first and the third equations. And so if I do that and take the first and the third equations and add them together, I eliminate the C, again, which is what I was trying to do, was eliminate the C. But now with this equation here, we now can go ahead and figure out a bunch of stuff. Because remember, I just figured out what B was. I figured out B in the last one because I had two variables cancel out. So I can take that value and plug it in. And so if I do that and take that B value of 10, plug it in for B, I can then go ahead and solve out for A, and I find that A is negative 3. And so when you plug in both the A and the B values that we found so far, you now can find C and find that C equals negative 4. So, I'm sorry, negative 4. And so now that we've gotten this far, remember, I now know what A, B, and C all are, but I don't yet have my final answer. Because remember with this, the final answer is the quadratic equation. So I'm going to take those values and go back to the generic y equals ax squared plus bx plus c. And I'm going to take those A, B, and C values that I just and plug them in. That then is my quadratic equation that I was going for. And we're done.